Hello everyone. Good afternoon. Sorry, I'm not able to be there with you guys this afternoon. Um, and excuse me if I would need to cough. Trying my best not to cough there, but excuse me if I would be coughing in this video section. So in this short video, I'm going to walk through this lab 4. And mainly our lab goals for this lab 4 would be to retain the course concepts that we had learned in the previous classes in structs and arrays and pointers. So we'll try out and practice some exercise on usage of structs. And before we do that, we want also watch the video from Professor Brailsford in University of Nottingham. He's a famous professor and a scientist and one of the oldest professors. So he talks about C programming in the series of video that Computer Phil series they have made. So we would watch those videos. There is two videos that we would be watching, and there's going to be we open up the lab sheet. There's going to be video reflection 1 and video reflection 2. So in these two files you would um, paste your corresponding answers to the questions from the lab sheet. And then if we go into the lab sheet, there's a link for the task 1 and task 2, so feel free to click on that link there, the YouTube link, and then you would be answering the 5 questions after you watch that video. It's a short video, just 10 minutes. I highly recommend the videos from Computer Phil and specifically from Professor Brailsford, because he talk about the evolution of programming and why C is so influential, and he also talks about pointers. So in task 2 again we have a video link, so you would watch that video and then answer the 5 questions listed here. After you complete the section 1, which is worth 20 points in our lab, we go into section 2. In section 2 we have the structs program, and where we would practice structs. So we go into the patients.c file, and the patients.c file has overall structure here to load up patient information. So also if you go into the lab sheet, there are 10 patients, right? So you have 10 patients, 5 patients in each floor, so you have the mapping table here. And what you would want to do is you would want to load them into the floor 1 and floor 2 struct patient. And you can see patient is a struct, a heterogeneous data type that has a patient ID, patient full name, their weight, their height, disease, and the floor. So here you can see the sample used here is already showing for the floor 1, 0. So you may want to do the same thing with floor 1, 1 to show the next patient, and then of course you're going to change the you're going to do the data entry work based on the table that's provided in here. And you would do that for 0 to 4, meaning all 5 patients. Then once you've done that for floor 1, you would want to do that for floor 2 as well, right? So for floor 2 again, you would copy that and then do the data entry where you type in floor 2 of 1, which is for the second patient in the second floor. Then you put their ID, the name, so on and so forth. Once you have done that, then the starter code would try to display that. If we don't complete the data entry work for floor 1 and floor 2, the display method would not work, right? So it will not print the expected answers. And the actual work is in the swap method. So if we go into the swap method, there's going to be comments here. So you may want to look at these comments and read that carefully. So we want to swap the patients in floor 1 with floor 2. So the expected result, you can see here, this two separate screenshot, but it is just one output, right? So you can see floor 1 and floor 2 display before the swap, and after the swap, all the patients are swapped to floor 1. For example, Chris Miller, Brian Miller, so on and so forth. The same thing with Alex Crow, and the other guys are now in floor 2, right? So you can see them, all their disease and everything in the floor 2. So you may want to play with that. So some tips are shown here. For example, in C, you can do this. You can directly assign floor 1 of 0 equal to floor 2 of 0. So meaning the first patient would go into the floor 1. And you may want to create the temp patient. So I've already created that in the starter code. So use that. And then you want to iterate a for loop that runs 5 times, because we assume there are 5 patients in each floor. And then you do the swapping so that the patients are swapped. And also keep in mind, you may want to assign the floor value back to the 1 and 2, because otherwise after you swap you will get the floor value to be 2 and 1. We don't want to do that. We want to make sure that the floor value is reassigned back to 1 and 2. So that's the actual work inside the swap method, and here we are trying to iterate through an array of structs, as we did in the class exercise, student array, student struct array. Similar to that, here we do for the patient, and we do a simple operation to swap the individual patients in each floor, right? So um, also you are recommended to try out the data way. If you don't want to hard code things like this, like floor 1, floor 2, then you can also have that in a data file and then read from the data file, as we would done for the previous lab. For example, the FBI program, you would have your loader similar to that and then read from the file. You're welcome to try out that approach, although that it is not required to do that. I would definitely start to make everything working by hot coding it, and then if you have some extra time and we're willing to try out something new with the challenge, then you could try that by reading it directly from the file. So that's our patient, and we go into the songs program. We are building a statistics. Again, the songs program, similar to patient program, has a very detailed and completed started code, so which means then your updates are very minimal. So first thing first is I want you to read through the source code and understand what every line here does. For example, it creates a data.txt file, creates a struct of songs. Each song has its name, number, count, rating, duration. Song number is like a song ID. Then you create a struct, an array of struct. Here we define the size as 15, and it can be 150, 1500, any number of songs, right? So the program is equipped to handle it by writing it to a data.txt file. Then we load it to the file.songs, file, songs. And I like you to read through this particular function. This function is probably the lowest way, or the low-end computing way of parsing a file, right? So we parse the file by loading it character by character, right? So character by character we read it. We have some flags here, F1 to F4, and then our goal here is to read each of those items which is coming in, comma separated. You read that when there is a comma, you know that there's a next item coming in, and you're welcome to run the program after you read through this few, just to get an idea and then understand how this operation being done. And you may develop a similar functionality for your course project, right? So um, you're welcome to read through that in detail. But the actual work in the lab is per se inside the report method. You see how there are like these 6 variables? We want to find out right now. Already the for loop will tell you how we can iterate through the songs array, or the array of struct, using songs of I dot song number, songs of I dot song count. But what we want to do is we want to make sure we find the least played song, most played song, least rated song, most rated song, then the shortest song, and the longest song, right? So you may want to go through the previous lab and the exercise that we did in the class. How did we find the lowest and the largest number, right? So you may want to iterate here, set up your iteration, and then find that accordingly for each of these. And once you've done, you would show the song number, displaying song ID, which is nothing but the song number. Right, so we want to show the song number. Here, let's go to the lab sheet and see the validation section. So here you can see we have 15 songs, and we try to show the least played song, the song number, which is 8, which is the count here is 1, and so on and so forth. The most played song is 2, which is 93, and we do the same thing for all those 6 queries, right? So we ask those 6 queries, and we try to compute it using our logic. So that's a short summary then about our individual tasks. And please make sure that you would upload your FBI, or I should say the files here, corresponding files, the songs, and I should say the patients.c file, and both your reflection files. Please make sure that you would upload that. If there are more questions, please feel free to connect with me in Discord, and I would be more than happy to clarify individually. Thank you for listening and watching to this video.